Hello, Sauce here. This lesson is on the Pythagorean theorem. There's lots that can be said about the Pythagorean theorem. What I'm going to choose to put into this lesson is a very direct way of explaining what the Pythagorean theorem is and where it comes from, and then a couple of simple examples of using it. What I've drawn here, I've started with a triangle, and because it has a right angle symbol in it, saying that this angle here is a right angle, then we call this a right triangle. The Pythagorean theorem only works for right triangles. And even though the Pythagorean theorem is limited because it only works with right triangles are the most common triangle that we use in math and science and engineering. Let me do something with the sides of my right triangle. First thing I'm going to do is I'm going to label these two sides, which we call legs, A and B. These are legs because they form the right angle. The third side, which is opposite the right angle, has a special name called a hypotenuse, and I'm going to label it C. A and B are legs. C is the hypotenuse of this right triangle. A hypotenuse is the side that's always opposite the right angle. I'm going to do a little bit more with these sides. I'm going to form squares based on each side length. In this case, I made a square based on the side length A. So all sides of this square have length A, and the area of this square is A squared. I'm going to do that with B as well. I'm going to take the side length B, and I'm going to form a square off of it. The area of this square then is the length B squared. And I'm going to make a square based on the side length C. The area of this square is C squared. Now here's what the Pythagorean theorem shows and says. That for every triangle, we can form squares from their sides, and adding the two squares formed by the legs will equal the area of the square formed by the hypotenuse. This A squared plus this B squared will always be equal to this C squared. We can write that mathematically. Side length A squared to find its area plus side length B squared to find this area is equal to the hypotenuse, side length C, squared. This algebraic expression here, where A, B, and C are all side lengths of a right triangle, is the Pythagorean theorem. And it must be that A and B are the legs, and the one that's by itself must always be the hypotenuse to set it up correctly. Let's use the Pythagorean theorem in a couple of examples. Let's say that we started with a triangle, and we know that it's a right triangle, and we have a side length of 6.8, which is one of its legs, and we have another side length of 6.5, which is its other leg, and we are asked to find the side length. Let's label X. X is the hypotenuse in this right triangle. How are we going to find X? Well, the Pythagorean theorem relates the three sides of a triangle. So if we start with the Pythagorean theorem, then our next step would be to substitute in the values that we know and use algebra to find the value that we don't. A and B must be the legs of the triangle, and 6.8 and 6.5 are the given measures. It doesn't matter which I substitute in for A and which for B. I'm going to choose to substitute 6.8 in for the leg A and 6.5 in for the leg B. And C is the hypotenuse. In this problem, it was labeled X. Now I have an equation, the Pythagorean theorem, with one unknown. I can use algebra to solve it. I'll need a calculator. 6.8 squared is 6.8 times itself, 46.24. 6.5 squared is 6.5 times itself, 42.25. This is still equal to x squared. Now I'm going to add these two. 42.25 plus 46.24, and I get 88.49, still equal to x squared. How do I get x by itself? X is being squared. That means x times x. The inverse of a square is a square root. So to get x by itself, I have to do the inverse of what I see to both sides. A square root of a square will cancel each other out, leaving x by itself. And now the calculator has to do for me the square root of 88.49. And I'll round this to the nearest thousandth. 9.407 is approximately equal to x. I have found the length that was labeled x, which is the hypotenuse of this triangle. I use the Pythagorean theorem and solve for it. Let's provide another example. In this example, I'm going to start with a triangle. And it's going to have a side length of 5, which is one of its legs. A side length of 12, the other leg, and another side of 13. Notice that I don't have a right angle symbol in this triangle. I have its 3 side measures, but I don't know yet if this is a right triangle or not. In fact, I should call 5 and 12 labeling sides. I shouldn't call them legs or 13 as the hypotenuse until I'm sure that this is a right triangle. Now, how can I be sure this is a right triangle? Well, if the Pythagorean theorem works only for right triangles, and the Pythagorean theorem, if I can show that the Pythagorean theorem will work for these side lengths, then I can show that this is a right triangle, if it works. What do I mean? Let's start with the Pythagorean theorem. I'm going to substitute in the values 5 and 12 for A and B, assuming that they're little legs, and 13 for C, assuming it's the hypotenuse. When I do, I get 5 squared plus 12 squared is equal to 13 squared. I'm not solving for anything, but I've set up the Pythagorean theorem. And if this equation is true, if the Pythagorean theorem works for these side lengths, then the triangle must be a right triangle, because the Pythagorean theorem only works for right triangles. Let's do the math. 5 squared is 25, 12 squared is 144, 13 squared is 169, and 25 plus 144 is 169. The result was a truth. 169 is always equal to 169. So these side lengths in this triangle made the Pythagorean theorem work, and the conclusion is this must be a right triangle.